Hello, hello. Good morning, everyone. Good afternoon or good evening, wherever in the world you are joining us today. Thank you so much for being here. My name is Adrian Sanchez. I am the segment manager with Legrand North America, and I'm very, very pleased to be your moderator today. We're very excited today to kick off our series of PowerTips Live. It's a series of webinars, interactive, and we have created this platform to provide answers to the most frequently asked questions about Starline truck busway and open busway as a matter. If you're with us today, that means you have already registered for the following series. So thank you so much. And by the way, we understand that there's a lot of options. These interesting times that we live in the world have offered a huge array of webinars and other education opportunities. So for that reason, we're more grateful to have you today. So thank you for that, for your virtual presence. Also, a couple of housekeeping. During the duration of our discussion, the microphones are going to be muted. However, if you have a question, please use the chat function on the control left or right panel of your screen. As soon as you have the question, please type it in. We're gonna do our best to answer that on the spot. But if for whatever reason we can get to it immediately, we will get back to it at the end of our discussion, or for sure, we will reach out to you after the webinar to answer that as well. So that's it. Our topic today is specifying overhead busway. And to guide us through this experience, we have the excellent presence of our expert panelists, which I'm going to introduce right now. So here in the right corner, we have Mr. Nick Fonjak. Nick is one of the senior industrial application engineers at Starline, Legrand North America. He's been with the company for 5 years, and his role is to provide in-depth technical guidance for the design, installation of industrial applications as a focus, but also for retail, commercial, and other areas like data center as well. Nick holds a mechanical engineering degree from Point Park University, and he has held various engineering, design, and other sales positions with other companies as well in the Pittsburgh greater area. And he's currently pursuing his MBA, so congratulations for that, Nick. Thank you so much for being here with us today.
Thank you, Adrian.
In alphabetic order, on the left corner, we also have Mr. Corey Leshen. Corey's one of the applications engineers as well. He covers the Eastern Territory all the way from Canada down to Key West, large territory. His primary focus is in data centers, but also just like Nick, he covers a wide variety of other markets, like I said, retail, labs, etc. Some great applications. Corey has been with the organization for 2 years, and he has held various engineering, design, R&D, and product development positions with companies like Kenny Image, Rayco Granite Suspensions, Pratt & Miller in the Michigan area. And he also holds a mechanical engineering degree, but he's from Case Western University. And he's, by the way, pursuing his MBA from Robert Morris University, just like Nick. So I guess, Corey, you are Nick's classmate too, right?
Oh, yeah.
Thank you so much for being here today. Well, for today's discussion, as everybody knows, today's market demands accentuate the challenges that businesses face in the design of the power distribution system. So our panelists today are ready to answer the most frequently asked technical questions on how to specify overhead busway, but also are going to help us to understand what are the considerations that we need to review in order to explore the overhead busway solution as the power distribution system of choice for our businesses. So that being said, let's get started. Corey and Nick, the microphone is yours.
All right, thanks, Adrian. All right, so like Adrian said, Corey and I are just going to go through this. We're going to keep it pretty informal. We're going to show you some examples. We're going to show you a few slides. We only have about 10 slides to show you, if that. So we want to keep it kind of hands-on here. So we're going to kind of assume that you guys have seen busway, have heard of busway a little bit, and some of you that have not, we'll go over the basics here. Corey's going to cover this here a little bit. So and what we want to have you guys get out of this is that we hope that your takeaway is going to be that you understand how to specify busway more. Obviously, you guys know where to use it. You know, you'll find out areas where to use it. We'll talk about those as well too. But mainly what we want to help you with is the specification of it, whether you're an end user, an engineering firm, or even a contractor. So, Corey, you want to take this one away here for the basics?
Absolutely. So we have a very simple layout showing the components that we have available for your system, for your layouts. In the data center industry that I specify most of my applications, they're usually straight runs. So it's a very simple bill of material, starting from the power feed where the field termination cables come in from the UPS or transformer, typically straight through straight sections with a bus connector and housing coupler in between. So it's for a straight run. For a lot of parallel run AB data centers, you may have only 5 line items on a specific bill of material. We even get into some U shapes where AB runs will cover both racks in 1 run, 1 feed. How about you, Nick? In industrial, I assume you see a lot more, some more complicated configurations.
Yeah, we see a lot of different variations in industrial, so industrial, it's much like data center, but we typically see longer straight runs. The question I always get is how long can you actually run a piece of busway? We run them in our own manufacturing facility a few hundred feet at a time without any issue. It's obviously there's voltage drop involved, but it's minimal when it comes down to it. So we see lots of different configurations, lots of truncating and T's and elbows in industrial. And then, guys, up in the top right corner over here, we're going to reference what we call a plug-in unit. So a plug-in unit, we hear lots of different ways. You guys will call them tap box units, breaker units. This is what we're going to consider a plug-in unit. I got one right here. Corey does as well, too. I'll let him show that one there. So that's what we're going to consider a plug-in unit as we move forward. So when we're talking about that, that's what we're talking about here. So one of the requirements, okay, that you need to ask yourselves, okay, so when we're looking to quote a busway system, all right, first of all, lots of questions come up. Where do we quote it at? Okay, so obviously data centers are a big one. Industrial manufacturing facilities are another large one. That's a growing market for us where we're seeing a lot more business coming up with the industrial and the manufacturing areas, assembly lines. So what you want to ask yourself is, maybe if you're a contractor or even an end user or an engineering firm, is does the customer plan to have growth? Okay, so as your business grows, as your customer needs grow, your power requirements grow. Starline ourselves, we are constantly growing year over year, and our factory and facility grows often. So does our customer needs. So it's good to have that plan for growth ahead of time. So that'll kind of qualify you. Okay, am I looking at going with busway or maybe a pipe and wire? So that brings us to the number 2. What kind of voltage is required? That's a biggie. We need to know as application engineers and as sales reps as what voltage is required in that facility. Some of them are 208Y, 120, some of them are 480 volt. Different facilities require different things. That's a key part here. We'll get into that a little further. And then on the ends of your equipment, there's different equipment in different facilities. Obviously, in the industrial manufacturing facility, I'm looking at CNC machines. CNC machines, routing machines. I'm looking at drill presses. Where Corey, you're probably seeing more of PDUs and IT loads, correct?
Yep. Yeah, and that's going through our list of questions. It's been interesting with COVID and how the internet itself has changed, where power requirements have grown, where a lot of our customers have ramped up from 30 amp to 60 amp PDUs and made changes in their racks just to utilize the space they have with the additional power capacity they have, with just simply changing out one plug versus any additional power routing, cable routing. Voltage, as Nick spoke, data centers increasingly going 240, 415, copying the overseas for the higher efficiency. But Nick and I certainly work with every customer on their application, and we have any options, whether that's breakers, connectors available.
Corey and Nick, it's interesting that the first thing you are recommending to our attendees is that before you get into the electrical specifications, it seems like they need to have thought about the nature of the business, whether you are an engineering firm or you're an end user. You have to think about the business side and have a system that is going to grow with you, correct?
Yeah, absolutely. It's always good to plan for that growth, and plan for your customer needs ahead of time. You don't want to be sitting there when you need to change and you need that along with everybody else. Corey made a good point with the COVID area, is everybody's looking to upgrade, so in order for that to happen, that's going to push lead times way back out with everything, the entire industry, even labor, down to the labor standpoint of it. So it's good to be on the forefront of that and plan ahead of time is what we're looking at there.
Absolutely.
And then one of the other things we're going to cover are your breaker options. Different short circuit ratings. The busway all has different short circuit ratings. We'll kind of get into that at a later stage in a different webinar. We'll dive deeper into those because that could take up some time on its own. But typical breaker options and whatnot are what we need as well too. Are they 3-pole? Are they 2-pole? 208 volt, 480 volt, you know, so on and so forth. And obviously the short circuit ratings. You know, what's the available fault current in the building? You know, typically as a manufacturing and looking at manufacturing engineering or facilities and whatnot, I'm typically seeing less than 22K. But I know in some data centers, you guys are seeing more like 35. Lots of times you're seeing 22K, and it could be higher in some situations as well too.
Absolutely. Yeah. So here's a simple layout of a data center. Obviously, most are much larger than this, but just as a simple micro view, we see here is an A row, a B row, 5 cabinets on each side, 5 30-amp cabinets with 2 PDUs, 1A, 1B, and 2 60-amp cabinets, each with 1A, 1B. So it's as far as a bill of material, as far as layout goes, it's really quite simple. But it's as far as sizing, specifying busway, busway is agnostic to voltage in the way very differently than some of the other equipment is, where we are amperage specifically limited. So whether it's 120, 208, 240, 415, 277, 480, we're looking specifically at the amperage of the system. Go ahead, Nick. So example for this AB run, we would have, each busway would have 5 plugins pulling 60 amps, each with 2 connectors going to each row. Then each would have a 60 amp plug or 120 amp plug-in with 2 60 amp receptacles. 80% NEC loading would bring us to 336 amps. That would push us to our 400 amp busway selection. So it's a simple math, simple, but it's, I think there's sometimes the industry leans more towards kVA versus the amperage that we use for our products.
So what you're looking at, Corey, is you're saying, like, and I've come across this quite often too, is we'll get the power rating of this I guess cabinet right here. You know, we'll have the kW of this, but what we're really after is the amperage of it, right? We need to know from the plug-in level what the connector is going to be, right? Typically, you're seeing IEC connectors, correct?
Correct. For most of the data center industry, we see would either be 5-pin 30 amp connectors, IEC, still a lot of L630 NEMA connections.
Okay, so that's what's important on these. So as specifying engineers, while you're going through these and looking at this says 30 amps here. We would expect a note somewhere would be beneficial to say, hey, this is a 5-wire, and if the NEMA configuration is known or the IEC 60309 configuration is known, it's good to call that out, right? It helps one, the PDU guys know what they're putting in there. It helps us from the busway side, the sales reps, and the end user as well too, to know what kind of cable they're ordering in that area there. You know, the same goes with the 60 amp too. You know, these could be lots of different options, especially at the 30 amp level. These could be pin and sleeves, they could be NEMA configurations. There's lots of different ones out there they could be. So specifying those is what's important as well too.
Yeah, the 3-phase 30 amp and 60 amp options we've shown here is a nice example for how quickly we can help specify what size Starline busway you need. But we'll certainly work with you on any application. And it's between the PDU, once we find out what that connector is, usually between that and the voltage, we can work upstream and help you size your system.
Yeah, and this is a simplified version of a data center. This is a small rack data center here. There could be a bunch more of these, but this is a typical simple example that we could share with you guys that shows the simplicity of this, right? And then if these racks changed over here, that's really easy to change that, right, Corey? You kind of got into that before, where if a customer wants to update this, maybe say they're a colo, right? Say it's a co-location area where they want to update this rack or bring something in different of their own. The customer has their own racks they want to bring in. You know, how quickly is that to change? You know, you can quickly change a plug, right?
Absolutely. Go ahead, Adrian.
Nick, I'm glad that you brought this up because, in fact, we have our first question in our chat. And the question goes, have you developed a plug-in unit that is less for UL for plugging in into the bus life? The desire is not to have to wear PPE while installing the unit in the bus. So I think that's related to what you're saying as well.
Yeah, it's similar. So we have developed a plug that is able to be live inserted into the busway. We have a letter through UL that allows us to do that. Ultimately, it comes down that we say, hey, it's up to the site location, the site maintenance and whatnot, what they want to do with that. We feel comfortable in our own site. There's lots of very large customers that we deal with that is the reason they go with busway, because of the flexibility. They don't have to shut down their other customers to add or remove a plug. So that is a benefit to it. As for the PPE, we do recommend wear the minimum rating of PPE. It is minimal, but there are locations out there, which I've been involved with, actually manufacturing locations where they've done arc flash studies on them, and they have found that these have a 0 arc flash rating on those. And that's all based on your facility, where the busway is located as opposed to people and whatnot. But this was, I think, 10 or 15 feet up in the air where they were able to put that rating on there after they found out that, hey, this is a safe system.
Yeah, Nick, and to add to that, for those situations where based on the upstream amperage, you have a high incident energy count, we do have a rotating paddle type plug that we can go into. We plan to go to in a later session. It's specifically designed to remove the operator from the approach boundaries when actuating the paddle into the busway.
Absolutely.
So we have options based on your specific application, your situation, that to meet whatever needs that you require.
Perfect.
Excellent.
And right here is, we always love pictures tell 1,000 words. Here's 2 examples of busway installations. The one on the right with the green and the blue are a great example of an A-B run, each with 2 drop cords coming out of each plugs crossing over to cover the data center. The one on the left with the silver and the blue would be a higher density system, or depending on the location, each has a single cord per rack. But it's just a simple parallel data center specific example that we have.
And one note too, so those come in lots of different colors. So this plugin right here is just a blue one. Everything gets powder coated on these plugins, so they can come in silver, blue, red. One thing that we note when you're specifying it, something good to do is to label those A and B runs, or you can paint them. You could paint one blue, one silver, or they have a tape stripe that you could run down. That's just a small 2-inch piece of vinyl tape that runs all the way down the length of the busway. That can be red, blue, pink, green, yellow, whatever color you wanted to label it as A run and B run. So keep that in mind when you're doing that as well too. And you can see right from these racks here, one of the benefits is the breaker's right here. So the customer doesn't have to go back, or the maintenance personnel doesn't have to go back to an IT room somewhere to check, okay, where is this breaker in relation to this unit over here, right? The cabinet unit. So they look up, it's right there, it's right associated with it. Everything's very close, really easy to use. So we're going to go into another example here. So this example is going to be a little different. Some data centers are related this way as well too, but typically I see this in industrial facilities. So this right here is a quick little draw out of my own house, right? So I have my own panel over here on the right hand side. I have a few extra breakers able to be placed in there, but I have a small house. It's a 100-amp panel, right? So each one of these circles that you see is a light. Those are 15-amp lights, and we have 20-amp quad receptacles at each one of these locations. Okay, so I just rewired this entire basement here when I first moved in. So when we look at it, we're looking at it, okay, so I know where everything's at. We're looking at 9 20-amp quad receptacles, 11 15-amp lights. If we added all those up together, we're possible with 345 amps. Okay, now notice over here, my panel is 100 amps. Okay, so one thing I come across a lot with busway is guys will go through and they'll look at all their machinery in their facility, and they'll say, hey, I have 3,000 amps total possible, coming into my facility, I need 3,000 amp busway, or I need 1,200 amp busways to be able to make up for that, which isn't the case. We tell them, take a step back and think of busway as one continuous panel. Okay, so busway is one continuous panel board that just runs 100 feet. Instead of this one little 2-foot section, it's going 100 feet, right? So the benefit of that is you get point of use breakers where you could drop those anywhere. But also remember that it is like a panel board where you're not going to be using everything in there 100% of the time at 100% of load all the time. Okay, so we try, and we'll give you some tips, and I'll show you another one here. But this is a good. I try to relate things back to something that everybody could relate to, which is my own home. When I went through and rewired this, I sat here and thought about this as I was talking to one of my reps and said, hey, yeah, you know what? I have over 300 amps, possible amps coming into my basement. But that's not the case because this is only half of my house, right? So what I want to show you here is that we're going to jump back and forth here. So this is a manufacturing facility here, okay? So one of the problems that came up, so the contractor, or actually it was the engineer that called me and said, hey, I have a problem. I have to have 8 of these receptacles all at one location. He called these a cluster, okay? So each cluster consisted of what you see on the left-hand side here, okay? You have 2 480 volt 50 amp 3-phase receptacles, some 240 volt, some single phase, some 3-phase. He said, hey, at every one of these little clusters, I'm going to have 8 of these receptacles, but I'm only ever going to use 1 or 2 at a time because I don't know what machinery is coming in here, and neither does the end user right now. They said it's going to be a very flexible manufacturing facility where they might have a drill press there, they might have some saws laying there, or they might have a CNC machine there. We don't know, and they don't know either, and they might move it around. So he needed this flexibility, okay? So up in the top right corner, I think Adrian actually took this photo. This was at a convention center. We're not going to say where, but this was at a convention center where you can imagine that one of these clusters, I'm sure the engineer would have done a great job with it, but one of these clusters would end up looking like this, right? If they're using it. This is right here on the right-hand side is just an example of a contractor just modifying. He's making do with what he's got, right? And nothing against that. He's trying to satisfy the customer, and that's where he's at. But there's a better way to do it. So what we looked at is we said, okay, you have all these clusters. When we added all those up, we were at like 6,000 amps. Okay, so here's a snippet, just a small corner of the drawing that we came up with. So you can see what we were talking about our clusters. Inside each one of these, there's a cluster about it looks like there's every few feet right on here, all the way through this facility. So what's that going to do? It's going to add a lot of cost to the customer, a lot of time to the contractor for the install, and for a lot of material you may never use, right? So we started talking about it with them, along with the rep. We started talking, hey, what are our options? And we said, here's what we could do. We could run some 480 volt busway down. We have some T's and elbows we could deal with, along with some 240 volt bus as well. So that'll take up your 480 volt receptacles that you have, your 240, and then down the line, if you decide you needed to add something that wasn't one of these receptacles, it's easy enough to do. So we said, okay, so instead of adding all 8 of these at every one of these clusters, you add one plug right into this busway when you need it. So the end user brings in his machinery, says, I want it to go right here, drops it right there. He comes over with a plug-in unit, turns it in the system, and he's got power. Right, so that was a fast, easy solution for these guys, and this was a job down in Texas, and they eventually did end up doing it. And but the other thing we were looking at was the amperage. They said, well, I have 6,000 amps coming in, possible amps coming in on each phase. Where do we want to go with it? Originally, we started oversizing the busway and said, well, that's not going to be the case. Most of these aren't going to be used. So we came down to a rule that about 65% is roughly where we want to be of your total load. Now, we always say, use your best judgment as well too. As engineers, we have to take a step back and say, okay, that's maybe what's recommended, but sometimes I may know that I'm going to need more. Sometimes I know I'm going to need a lot less. In this situation, we said, okay, 65% is a good base, but we're probably going to need a little bit less because we're not going to use every one of these receptacles that you see on the screen all the time. That was the 6,000 amps was based on every one of these all at full load amps. So that's one solution that we were able to take from a manufacturing standpoint, look at this and say, okay, what can we do to help the end user, help the customer, help the contractor, all in one? And this was a perfect example of it here. Much like Corey was saying before too, You know, in the same thing, same sense of a data center, you know, they may have L630 plugs, 30 amp two-phase plugs somewhere, but they might need a 60 amp right next to it. You know, co-locations are like that all the time, right, Corey? You deal with those more than I do.
Absolutely. And that flexibility is what's convenient to be able to swap out, whether that's amperage, connector, whatever device they have very quickly, and you know, not tearing a raised floor up, not doing anything complicated or to the structure to be able to do it. And Nick, the picture you have on the previous slide is always, we'll say, near and dear to me, just because of, you know, as EHS requirements increase regarding not only, you know, reducing the amount of extension cords from a electrical fire point of view, but also just trip hazards from the safety point of view, where we have, if you've ever been to our factory, we have, I believe, T2, T3 busway about every 8 feet in the air. And there's not one place you can step in that factory where you have to step over a cord to get to something. So it's,
Absolutely.
we have it set up, we set ourselves up for growth. You know, we've added 2 or 3 CNC machines, at least since I started here, or at least added larger ones to meet up with demand. And it's, by the time the machine gets installed, the cooling fluid gets added, they have power and they're ready to go. It takes 45 minutes to install.
Real little downtime. You know, you could have your machine there, delivered, up and running within the same day.
So not only the savings and installation, the less receptacles or the flexibility, but it seems like we have here in the screen also more different type of plug-in units and combinations, right, for the specific power needs, right? It's like spreading your panel board throughout the facility.
Yeah, absolutely. And we'll cover a little more on this. I know we're starting to run out of time, but we'll cover a full section just on plug-in units. But we wanted to show you an example of what a plug-in unit looks like, right? So I got one sitting right here. You know, these come with lots of different options, right? This has a meter on it. Weatherman, I can't do that backwards. So this has a meter on it. You know, you have your receptacle, and then you have your breaker. You got your options on here too with your, like, this is a shroud, you know, a breaker, interlock. You have different options like that. And it's not limited to just one receptacle per unit. You know, you can see on the screen there where we're using 3, 4. I think, Corey, you've done ones that are up to 8 drop cords on one plug-in unit, correct?
Absolutely. So I have done I think that's about where we tap out is 8 drop cords, and that's more because depending on the length of the cord, the plug gets quite substantial carrying that much SJO or SO cord around. But it's,
sure.
Yeah, we wanted to briefly show just capability to keep your minds open in regards to how you were specifying these plug-in units. So whether that's circuit breakers, fuse disconnects specifically for reducing the KAI see-through, or just a fast blow for an application, you know, multiple breakers, multiple receptacles, drop cords, even the cord reels that, Nick, I know you see a lot of those in the industrial market.
Yeah. And most of these are all what we consider just a custom unit, you know. So, and by custom, we mean that we'll make anything that you want. Anything that the customer wants, we're going to make it, right? As long as we can abide by UL 857 and NEC codes, we could do that. Lots of times, and by custom, we mean that it's not going to be a long lead time or anything like that. That's just our business, right? So when we're looking at plug-in units, so I get a lot of times in the industrial facilities is guys will tell me, hey, I need a 520 quad, I need an L630, I need an L1530, I need them all in the same plug-in unit. Can you do that? Well, sure. You know, that may not be one that we've done before, but we could do that. That's not a problem, you know. So we'll get in and dive deeper into these plug-in units and their options at a later date. One of the other webinars that we have coming up will cover a lot of that, and basically what you need to specify when you're looking at a plug-in unit. But one thing I do want to make sure we cover with you guys, and this is very important, is your feed conductors. So as you're specifying busway, you have plugs or some type of landing point inside of your end feeds. Okay, so you either have a standard lug, which is like this here. You know, you have the mechanical lugs, you have the compression lugs like this here, or you have a larger 4-hole lug with this one here. Okay, we can accommodate just about anything in these feeds. We just have to know about it. Corey and I have this conversation all the time. We always get the conversation of the contractor calls us and says, hey, I pulled 350 MCM wire, aluminum wire, because I had to go a long ways with it. We were making up for voltage drop, but I can't land it to these lugs because these lugs are only 300 MCM. At that point, we're stuck, right? So as specifying engineers, we need to let the contractors know that, hey, if you're going to pull 350 MCM, or if I'm the engineer and I'm going to spec 350 MCM, I need to make sure that the ending of that is going to match up with what I could do. I got to make sure I can land that wire onto some type of lug. We have the ability to do that. We just need to know ahead of time is all, right? So if we don't know that you're bringing 350 MCM in and the contractors there ready to install, now they're held up on the job for something so simple. So we recommend when you're looking at feed conductors, take a look at the O&M manuals, reach out to us. As engineers, we're going to give you a hand and tell you exactly what you should be running with those. You know, we'll take a look at your wire size and say, yes, you're going to fit, or no, you're not going to, right? So I know most of the industry is moving over to these bolt lugs here. A lot of data centers are doing that, Corey, right? And it gives them huge flexibility, right? They could bring in a compression lug that fits 300, 350, 400, you know, whatever they need. It's a lot more flexibility as long as their hole spacing is the same on the 2 bolt lugs. So pretty common to use the bolt lugs. That's kind of an area where you can't go wrong, and you won't screw up the contractor in the field either. So I think we're trying to shove a lot into a half an hour here, but we appreciate your time and we don't want to take up too much of it. But what we want to kind of give you guys an idea of is where you guys can find help on this, right? So if you come across a project where you're curious about busway, or you're looking towards specifying busway, there's lots of options, right? You could take a look online on our website. You could email us, or you can call us by phone. Inside, all across the globe, we have regional sales representatives in your area that are very well trained, and these guys know their stuff. They know busway like the back of their hands, right? So they're going to be an extension of us, and eventually they'll probably get a hold of us for pricing or just some projects specs as well too. So eventually we may end up talking with you along with the rep. But these guys are in your area, they're close by, they can come take a look at your facility and use them as a resource as well. They'll give you a hand with that. So if you email any of these or call any of these, you will eventually get redirected to that rep there for you. And then they'll take care of you from there. But Corey and I are always available, along with the rest of our team of application engineers across the globe. All right.
Thank you, Corey and Nick. At this point, we would like to answer any pending questions that we might have. So if you can type your question on the chat function of the control panel on the right-hand side of your screen, we'll be more than happy to ask Nick and Corey to diligently answer that.
Sure. Yeah, if you guys have any questions, let us know. You know, you can type them right now, or if you prefer to answer them offline, that's fine as well too. Shoot us an email, and then we'll absolutely get back right back with you and answer any questions you might have.
Well, we get another question. Can we briefly talk about, it is my understanding that for engineering firms, when they specify the busway, they can utilize a certain length of cord that will allow them flexibility, considering that they don't know the exact location of the small load is going to be at the end, right? Can you explore a little more on that?
Yeah. So one of the benefits, especially in an industrial facility, is you don't always have to know exactly what's going there, right? And how long your cable is going to be. You know, so you might move a piece of equipment from the left and move it 10 feet over to the right-hand side. And you can do that easily with busway, because either one, you go up and you unplug it and move your busway plug over, or you have a cable length that's long enough, you know. You basically just specify those as, hey, I need a 10-footer or a 20-foot cable length. And that's the way it comes. You know, if you don't need it, you tie it up, loop it up, tie it up with a Kellum up top, and you're done. You know, it's real simple, real flexible in those manners. One example with us in our own manufacturing facility, you know, we have customers that come in and say, hey, I need a lot of these plug-in units. There might be 5,000 plug-in units, and they need them in a specific time. So our own facility, what we do is we reorganize those lines. Our manufacturing engineers get together and say, hey, let's reorganize our stations. Let's move our stations to another facility if we need to. And we can do that because the flexibility of the systems is there. You know, we use obviously Starline busway in our facility, where we could reconfigure these systems in our workstations very quickly. to the point that we're doing it overnight. And then we're back up and running, and we have an efficient way of building these 5,000 plugs and delivering them on time, right?
Excellent. Thank you. Well,
Okay.
seems like we don't have any further questions from our attendees. As a matter of respect and to time, this concludes our discussion. I hope that if you're an engineering firm or you're a contractor or distributor, or if this is the first time that you're introduced to these type of systems, I hope that you found this worth your while. I'd like to thank our panelists today for their valuable information. Thank you so much. And as I mentioned, if you join us late, I'd like to recall that if you are in this presentation today, you already signed for the following webinars. We're going to have one next week on Tuesday at the same time, 2 p.m. Eastern in the US. And the next topic would be customized layout design and polarization. So our engineers will be talking more in depth on how to cover that portion of it. And that being said, my name is Adrian. Once again, thank you so much for your time, and be safe out there, okay? Thank you.
Thanks,
Thank you, guys.
everyone.
Take care.